Hey, hi everyone. I hope everyone is doing well and really enjoying the relevant content related to product manage. I think we are going to shift gears now since you guys know that there is a lot of demand to at least understand concepts related to cloud deployment. And in pretty much, I think, interviews you can expect, I think, discussion on this. In one of the recent interviews that I have been part of, there was a lot of emphasis on understanding of Amazon AWS, so which is what I am going to share with you here, right? So without, I think, getting into too much of details of what AWS is capable of, because AWS is obviously running more than 200, 300 services, right? Uh, Obviously covering all of those is beyond the scope of this video, and I think at some point we might touch upon all the main ones, and then I think you'll see, I think, how, let's say, designing a platform, for example, comes into picture, right? So stay tuned, I think, for that part. So let's jump into, I think, the services offered by AWS cloud. I'm also going to show you how the console looks like. So it's not just going to be all theoretical, right? Let's just cover, I think, the basics first, right? So Amazon ECS, right? What is it? It's like an elastic container service, a fully managed, like, container orchestration. A lot of jargon here, but I think essentially it is going to help you run, manage and stop your Docker containers on a cluster. Like, you can consider a cluster, that is present in the cloud environment, correct? Why is it required? It's easy for developers to run distributed applications, on a scalable infrastructure. So that's, I think, the key part. Now you can ask, obviously, what is a container, right? What do you even mean by a container when you're saying that this is a ECS is basically like, a fully orchestration of a container? What does it mean even to have a container? So container is nothing but like a packed up code, right? This is basically all the dependencies of a code. So I'll take you to a very basic example, which is, let's say you are running a code in Python, right? So you would have this import on the top, right, where you're importing, let's say, certain libraries, certain packages. If there are some environmental variables also, if you have done Python programming in the past, you know that in some cases you might have to also declare some environmental variables, right? And without that, I think you can't, let's say, for example, run certain libraries. So all of that and much beyond that, I think what is going to refer to as the packages, right, of you coding in a single, let's say, a Jupyter notebook, right? You want to ensure that all of the dependencies of the code are packaged nicely, right? That is what a container is referring to. And obviously, applications then run quickly, right, from one computing environment to another. Um, I think the basic idea behind that is that behind a container is that it helps you identify and simplify the deployment and management of applications, correct? I mean, you can obviously, efficiently scale. You can also identify the resources, and then you can obviously, look at portability between different platforms, right? So that is what a container is, correct? Now, what is this ECS that we have been talking about, which is a container service, right? So when I talk about services, it is like you can run multiple container services, correct? This is how the console of a container ECS, which is Amazon's. Similarly, there is going to be a similar service for, let's say, Microsoft, and there's going to be a similar service for GCP as well, right? You log in into any of their consoles, you'll see, like, I think, a similar, let's say, a similar kind of a layout, right? Now, what is it that ECS allows you to do, right? There's a bunch of things, obviously. You can define your clusters, you have your namespaces, have your task definitions, and obviously you can go to the account settings. So let's just actually quickly go through one of the, let's say, ECS console. So you have to obviously create an account with AWS. It requires for all the, like, details of your card and all of that. But I think once you pass that, you can actually look at, let's say, what are the services that are offered, right? So here, for example, okay, this is the next part of the video, but I'm just going to show you how an ECS, dashboard looks like, and obviously what are the different aspects related to an ECS instance that you can actually do. So this is the console that is just coming up for you, right? There is, I think, clusters that you can define. Like if you click on the create cluster, you can obviously define, let's say, I don't know, maybe just define a cluster name, and it is obviously going to give you a namespace. Namespace is like space on the cluster where, like your like a group of clusters. A namespace within a cluster would be where you are actually going to, let's say, run any of your applications. Correct. um, this is what I mean. There are obviously instances like, do you want to do a manual configuration? Fargate is, I think, one of their applications which is running a serverless, instant, which means that you don't have to worry about scaling up and scaling down the server as the applications grows or reduce it. Fargate, will basically take care of. I'll cover it in a separate video. Don't worry about it for now. Right. So you have, I think, you fill out, I think, these details, right, and then I think you click on the create button. Now, obviously, it goes through some creation process, wherein, like your cluster could be created. Remember, like, I think there's also an option to select on what locations I think you want to create your clusters, right? Some locations are not enabled, for example, as you are seeing. Uh, I think the last time I obviously tried creating a cluster, it resulted in this. For whatever reason, you can see, like, I think test is what we, like, were trying to create, the creation in progress. The creation failed for whatever reason. I am not sure, but I am sure, like, I think if you go back into the details, I think you should be able to understand, right? So I hope, I think, you are able to understand, like, what does it mean by creating a cluster now in a container. I think obviously there are meta information related to this cluster. So, for example, how many, let's say, resources this cluster is using, any parameters that you want to specify with this cluster, correct. You can obviously also look into the stack info. Where is this, like, cluster actually running, right? So if you click on this, for example, it will take you to the actual, like, URL where you are going to see the cluster. So remember, we had created the test cluster, right? So this is what the cluster is. And cloud formation is nothing but it is going to tell you, for example, the full name of the stack. It's the URL stack that you can use to actually identify, right? So now, for example, coming back, it says that cluster is created, correct? It's the same thing. Like, if I go into the test, I can look at, like, what are the tasks, let's say, maybe that I have, like, created. Now inside this, for example, right, once I've created a cluster, I can obviously create services inside it, right? What are these services? I think bunch of services that you can, like, obviously use, inside this. Um, I think some of this is going to be very heavy on information, load balancing, and service auto scaling, for example, right? I mean, these are obviously going to require more, like, coverage as far as that is like, understanding is concerned. But you now understand what do you mean by a cluster, for example, right, on the Amazon AWS instance. Also, I think related to that cluster is, for example, you want to maybe create a task. It might be an automation task. I don't know. It could be any other task, deployment task, right? You can use that. There's infrastructure related, I think, for example, tasks. Infrastructure related, sorry, details that you can fill out here, right? And then there's metrics, and then obviously scheduled tasks, right? If you have scheduled any task that you define here, right? I'm quickly going to jump into namespaces now, right? So here, for example, our namespace was given as test. It has some ID and it was created in this. Tasks, you can also like, create, let's say, a new task definition, right? You can go ahead and very well do that. I think tasks are obviously going to require you to specify a lot of infra requirements. So, for example, you'll have to identify the operating system on which you are going to run this task, number of CPUs, memory that it takes, right? What is a task role, for example, right? Execution role. I'm quickly giving you a glance. We can cover this in detail when I'm also going to cover, let's say, creation of an application, right, in some later videos. But just have a look at, like, I think the amount of detail I think that you need, for example, to run a simple task, right? And obviously there's a lot of options where you can give timeout limits. There is a storage, I think, option as well, right? Environment variables, as I was mentioning, right? You run some programs, for example, you might need certain kind of environmental variables. Memory, I think, obviously you can increase the memory. You can also increase the number of CPUs, right? Which means that obviously you're going to pay more, right? And I think looking at the account settings now, I think this is just looking at your own account, and there are obviously options for other users as well. We'll not get into the details, but I hope you got the idea of what an ECS means now, right? You're not going to be left with an expressionless face, but this is what ECS is. And also, like, I think use cases, right? Let's get into the use cases of ECS. You can run, I think, essential use case, the most important one, I think, is microservices, without a doubt. You can run, you can manage and scale, obviously, your microservices. We have talked about microservices. If you recollect, I think any of my, let's say, videos on, I think we did cover microservices in, definitely we covered it in the types of architecture, right? Monolith versus microservices, correct? So just quickly giving you an idea, monolith was this, and microservices where, like, multiple services are running, right? So use case of ECS is running those services on the clusters. So now, are you able to connect the dots, right? This is what it means. When you actually clear the basics, I think this will make more fun to learn. So that is my attempt. Uh, Keep the basics very clear. I think understanding the cloud technology is going to take effort, but it should be fine if your basics are clear. So I think on microservices, like, you can obviously scale microservices. Your obvious components are packed as containers, and ECS can manage pretty much everything with the scheduling, orchestrations, right? I mean, everything related to the Microsoft. DevOps is also a very special use case, right? Uh, Developers can basically quickly spin up and manage containerized applications in continuous integration and continuous delivery, CI/CD. You would have heard of this term, right? What it means is that, for example, if I am running, let's say, an application in one maybe pod, or one of the, like, in the drop down I was showing you instance area, right? Let's go back to that part. This guy here, right? This was running in Sydney. Imagine I want to run this same maybe setting configuration of clusters in US East and Virginia, right? So which is kind of some sort of a development operational work, which I am repeating over a period of time, right? The code could be the same. It's just that I might have to change certain parameters, for example, to run that code in a different geography, right? On a different geographical cluster, right? So that is what, roughly what a DevOps would mean. Legacy applications, yes, ECS can also be used to monitor, modernize existing legacy application by, like, just packaging them into the containers, correct? High performance computing, ECS, I mean, obviously can be used in high performing computing workloads. Um, I think EC2, I'll touch upon that, but just understand what are these high performing, tasks. These are, like, I think, computationally intensive task that you want to run, like, let's say, for example, running simulation or data analysis and machine learning. Now, with the advent of large learning models, if you have been reading about machine learning, you'll realize that this high performance computing has now become even more important, right? So we can discuss that more in detail, but think of, like, I think, high performance computing as some sort of super computation, right? Internet of things, of course, like, your sensor data, IoT devices, right? You can containerize those applications and analyze the data in real time. So that is, I think, all we had for ECS, right? And now coming to another service that Amazon AWS provides is the AWS Lambda. And what is it? It is a serverless computing service provided by AWS. Serverless means you don't have on your instance or on your premises, where, let's say, you have your technology teams and all, you don't have to worry about installing any servers. It's a serverless computing service provided by the AWS. You obviously can run the code, correct, without having to provision or manage servers. This is taking away the server administration jobs. You don't need to do it. Amazon is basically doing it for you. You upload your code, Lambda will run it, response to specific event or request, and then only change, as obviously these events change. The charge is only going to be on your card or whatever company account on the compute time that is used, not on anything else, right? It's obviously very scalable, and it is a cost effective way to run the code, uh, because it is charging you only for the execution time. It supports multiple programming languages. I've seen, like, I think, bunch of programming languages: .NET, Python, Java, all of that. And making it, like, obviously it makes it a versatile tool for building serverless applications, correct? So this is how the console looks like. We are going to get into the details like we did for ECS, but just understand, right? I mean, here also there is a lot of, I think, information. You have errand count, success, basically your account level information, throttling, duration, and then applications and functions. So let's just quickly hang on. Let's just quickly jump into, um, yeah, let's just look into Amazon Lambda. So search for Lambda, and I think you should be able to see it. Now, I think the interesting part about this whole console is that you see, like, I think there are a lot of blogs, FAQ documents. I'm sure that's a lot of knowledge that is already available. AWS, by the way, also has its own, set of YouTube videos. Do check them out, like, go ahead and check it out, right? So this is what exactly what I was just talking about. Lambda lets you run your code without thinking about servers, right? I mean, bunch of, like, let's say, languages, right? So let's jump into, let's say, the dashboard, right? So again, I'm like, trying to give you a glimpse, but this is by no means going to make you an expert and tomorrow you start creating application, but it will tell you the possibilities of what can be done with AWS Lambda, uh, right? So dashboard obviously is going to give you a lot of idea about your application. um, Serverless applications, obviously you have to create. Now I'm going to give you a glimpse of what are the applications that you can create, right? You can create your CI/CD pipeline application, serverless API backend, right? You can create file processing, right? You can schedule jobs. You can also use notifications. You can use queue processing, right? Queues, I think you remember, right, from our discussion on message queues, right? So that is the same queue that I'm talking about here, right? And then looking into the serverless applications, what are a bunch of, I think, serverless applications, right? For image processing, for example, simple application of, like, Python programs, Alexa, I think, right? So there are obviously quite a few, I think, public applications already created. You can reuse those, change the code, and deploy it. But understand this, that the scope of Lambda is definitely to help you scale, and the use cases are, a variety. I am not going to create any application as of now. We'll jump into that when I think that appropriate time is. Coming back to, I think, the use cases, right? So use cases for Lambda, I mean, as you saw, right? The backend for web and mobile applications. This is this is the part where you saw serverless, let's say, applications or serverless API backend, right? And then looking at, let's say, the implication of that, right? So, like Lambda can be used, like for the backend for both web and mobile applications. It's not just limited to only web. And obviously, what are you going to do with that application? You're going to use to process user request, handle authentication, bunch of other tasks that you can do, right? Data processing, again, like large scale data. Think of, like, I think millions and billions of records of customer where you want to like process and analyze, right, the data from various sources. It could be IoT devices, log file databases, whatever it is, right? Source of data, but then just the processing. It can be triggered by, obviously, very specific level of event. So, for example, adding a product to a cart in Amazon is an event, right? You want to analyze that. It is at that scale. An event could be anything. A click of a button on a mobile app, that is an event, right? So, like new data arrival, and, like the processing obviously happening in real time. Right? That's the beauty of it. Automation, obviously, you can imagine that when the scale is such a high scale, right? Automation is obviously going to come. So tasks and workflows, right, such as sending email, generating reports, responding to, let's say, user requests. All of this is repetitive, right? And every time there is a trigger, you should be able to repeat that task. So, which is what automation. Serverless APIs, obviously, Lambda can be used to create serverless APIs, as we just saw, right? Can be scaled without the need for a server management. And it can be integrated with services like Amazon API Gateway, right? We'll touch upon this when we are looking at a real application. Chatbots and voice assistants, no need to explain. You can easily create chatbot and voice assist, right? It can process, obviously, natural language inputs, speech to text and text to speech, whatever it is, right? I mean, provide responses in real time. Now, I'm going to touch upon the most crucial part, which is ECS versus Lambda, and why should you actually care about these two? Why you should understand the differences. We covered both of these in details. I want you to understand that where is ECS more useful and where is Lambda more useful, right? So, an example of where it would be more appropriate to use Amazon ECS, right, over Lambda would be where you are running, let's say, a long running continuous process that maybe, let's say, requires a lot of storage or persistent storage, that maybe a caching service, for example, or a database, right? uh, ECS basically allows you to run these types of applications. You can containerize those, right, which can be easily scaled up or down based on the demand, right? So this is like a very special, like emphasis on this. I'm again telling you that when you are running continuous processes, that need the entire application, basically, right? To be running over a period of time, a continuous, let's say, deployment, right? That is when you'll think of ECS, right? Um, Lambda, I think, obviously is more suited for them for short-lived, let's say, use cases, event-driven tasks, right? That can be completed within few seconds, like data processing that you want to do. So you might be doing it, let's say, once in an hour, for example, maybe once in a day. I don't know, whatever frequency you set, right? And then you can obviously look at user requests, right? Login requests, right? When you're logging into the API gateway, allowing that, it can handle all of that. And automation, of course, right? So, and just to summarize, right? I mean, in general, ECS is a better choice, I think, for applications that require, like, I think, storage and continuous, let's say, processing. Whereas Lambda is better suited for event-driven tasks. We had touched upon event-driven architecture also, if you remember it, right? So if you are trying to implement that, Lambda would be definitely a better choice, right? So with that, we come to an end of, I hope, an intriguing and useful Amazon AWS Cloud Part One introduction. I'm going to cover, I think, more services, in the coming few days. Idea is to familiarize yourself with what AWS has to offer. And can we go ahead and maybe create an application? Yeah, sure. I mean, I think that is also a possibility. I'll see what I can do to, like, help you understand these terms. If you understand, I think, these terms, you can go ahead and appear for any interview, I think, for cloud. Of course, not on the technical side. I'm talking purely from the product management side. I think this should be more than enough for your knowledge, right? So until next time, stay tuned. And if you haven't subscribed, please like and subscribe to my channel. Thank you.